And look at those first 6 warm-up problems. On number 6, that 6 kind of got pushed down to the next line. So it should be y plus 6, where it says to FOIL. It just got pushed down on accident. Okay. For example 1, remember we're looking for the GCF, so you are looking for what you can take out from both sets of terms. So both are divisible by 4, both are divisible by x, so you have 4x times the quantity 5x minus 6y. In example 2, 16, 24, and 40 are all divisible by 8. And all 3 terms contain a y squared. Therefore, we are able to remove an 8y squared from each term.
thus leaving us with 2x minus 3z plus 5. So again, these are not factorable in terms of turning them into binomials. This is simply factoring using the GCF. Example 3, you have x squared minus y squared. X squared and y squared are considered perfect squares. So we have the case of two terms with a minus between them, which is a difference of squares. So you get x minus y, x plus y. So again, each of these problems we're kind of looking at are problems we talked about and factored last week. Okay, number 9, take out a GCF of 2. Now again, when we take that GCF out, we're left with 9c squared plus 4d squared. Because this is two terms, and yes, they're perfect squares, we think, oh, difference of squares. However, because there is not a negative between them, it is not a difference of squares. Therefore, we just have 9c squared plus 4d squared. You cannot factor that further. Okay, and then for this one, these were perfect squares, and they had a GCF. Now, not all of us saw the GCF, so we might have had 2m minus 8, 2m plus 8. Some of us might have had negative 8 plus 2m, positive 8 plus 2m. You could have had 4 factored out, m minus 4, m plus 4. Because again, what we could do is rearrange the terms so it's 4m squared minus 64. So that's where these two sets of answers are coming from. If you did not, but you saw the difference of squares, you may have gotten this answer down here. All of them are correct. Okay, and then the last one, like I said, you had to make sure you moved that 6 up, and then you FOILed. You have 2y squared plus 14y plus 12. So we have the cases from last week. So case 1 and 2 are when the last term is positive. The factors will have the same term as the middle sign. Case 2, when the last term is negative, the factors will have different signs. So that's what we focused on Friday. We had case 1, 2, and 3. What we're going to do today is expand on those cases, and we're going to talk about, okay, how do we factor if there now is a term on the x squared? So what I mean by having a term on the x squared is in example 1, you have 3x squared plus 11x plus 6. On Friday, we would not have had that 3 on the x squared. All of our terms were x squared to start. Now, what we have to do is we have to change our magic x a little bit. So it's still going to be the factors and the sums, but now to get the top number, you have to multiply the outsides. So it's going to be 3 times 6, which is 18. So it's 18 on top, 11 on bottom. So we have the factors of 18 that sum to 11. Okay, Jonathan?
9 and 2.
Good. So what we're going to do now, and this is a little bit different than before also, is these two terms here are going to replace the middle term there. So it becomes a little bit more challenging when we have a number out in front. So now we have 3x squared and our plus 6, but we're replacing the 11 with a 9x and a 2x. So you can see that if I actually added 9 and 2, I'd get 11. And think back to last week. If you had 4 terms, we used what method? Grouping. So what we're going to do today is group the same way we did factor by grouping. So you're going to group the first 2, you're going to group the last 2, and you're going to look for a GCF. So everything sort of comes together in today's lesson. So we're using everything we've done. We're using GCF, we're using factor by grouping, we're using our magic X. So GCF here is 3x, so that leaves an x plus 3. GCF here is 2, so that leaves an x plus 3. Remember that when we do factor by grouping, we want what's left in the parentheses to match for both terms. So that becomes one set of parentheses, and then what we grouped and factored out becomes the other. So you can see where the magic X and putting in the 9 and 2 for these last 2 numbers would not work anymore, because that's not what they are. What's nice is if you do the magic X this way and you do the factor by grouping, it works even if the number on the X squared is 1. So you could take any problem from our homework over the weekend and do it this new way and they will still work. So you don't have to actually tell the difference unless you can see it like easily and you understand it easily. But this method will work for all factoring problems. So you can do any of those cases over there with factor by grouping and the magic X. Okay, let's look at example 1b. We have 4x squared plus 16x plus 7. So same idea, multiply the 4 and the 7 to get yourself 28. So I need factors of 28 that add up to 16. So factors of 28, what do you think? Yep. So once again, we're going to replace the 16 by 14 and 2. Group the last 2, group the first 2. Find your GCF. If you look at the second set of parentheses, you have 2x plus 7. The GCF of that is simply a 1. Since I can't take out a number and I can't take out an x, it's always just a 1. What's in my parentheses matches. So I get 2x plus 1 and 2x plus 7. What I want you to see is how this is actually, don't flip over yet, FOIL in reverse. If I told you to FOIL 2x plus 1 times 2x plus 7. So if I said, hey guys, FOIL this, you'd say, all right, first, outer, inner, last. Do you see how this line here is that line there? So this method that I'm showing you, another name for it would be like reverse FOIL. Because then if you do what you do in FOIL, which is to combine like terms, again, we can see how we end up with the original problem. So again, the method that we're kind of doing today is reverse FOIL. You're essentially taking FOIL and working it backwards. Okay. Example 2 is the trickiest of all the examples. Example 2 is the trickiest of all the examples. That is because of the case. So example 2 is like case 2 from Friday's notes. So this is the case where you have ax squared minus bx plus c. So this is the case that when you get to your final answer, your parentheses are both negative. And the reason it makes this one so tricky is because we have to have 2 negatives in my magic x. So this is the case that you have to pay the most attention to. So we have 5x squared minus 13x plus 8. So outside terms, 5 times 8 is 40. Bottom term is negative 13. So I need 2 numbers that multiply to give me positive 40, but add up to negative 13. So if you have a positive on top and a negative on bottom, perfect. Both numbers here are negative, and that's what makes this tricky. Because when we replace the middle term with 2 negative numbers, we have to watch our GCFs. So you get 5x squared. And it doesn't matter if you write the 8 or the 5 first. You can write minus 8x or minus 5x. When you group them, you have to keep the negative inside the parentheses. That's what makes this tricky. What can I take out of 5x squared and 8x? X. If I need this to be a negative 8 to match this, what do I have to take away from this parenthesis? What do you think, Troy? Yeah. I want to GCF out a negative 1. So what that does is if I take a negative 1 away, I get 5x minus 8. Now my 2 parentheses match. And I get 5x minus 8, x minus 1. Both factors are negatives. So again, example 2 is the hardest example to factor. Okay? And the third example, 3x squared minus 4x minus 4. Magic X says multiply the outside, so you get negative 12. Put your bottom. So I need 2 numbers that multiply to negative 12, but add to negative 4. So it's going to be 1 positive and 1 negative. Flip it. You want negative 6, because you need a negative down here, so that your bigger number to be negative. When you have 1 negative and 1 positive, when you do your factor by grouping, always put the negative first. So when I write it over here, I want to write it as 3x squared minus 6x. I always want the negative to be first. If one of these is negative and one is positive, I always want to write the negative first. It'll make it easier in the long run. Group them. Otherwise, the order you write them doesn't matter. 3x, x minus 2. Take out a 2. You got x minus 2. Okay. Due to our delay, we're not doing the bottom, so put a big X on it, and your homework's coming back now. What? We're going
Who sits in your table?
Wow. Hey, Conrad, I think you're gonna be here. Come on, I need you to